Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's program is photographing the night sky. And with me here in the studio is one of the members of the Ford Amateur Astronomy Club, Tony Licata. Tony, glad to have you on the show.
Good to be here. Good to be
Great.
here.
Well, we're going to break this program up into two segments. First, we'll talk about the equipment, and in the second part, we'll get into the pretty pictures. So let's start with the equipment.
Okay. So what we have before us is my rig, one of my rigs. We're going to kind of go from the most simple equipment to more complex. So we won't touch on this yet. If you're interested in starting out in astrophotography, you don't have to start with this elaborate of a system. By no means is this as elaborate as it gets, but you can start with something as simple as a camera and a tripod. These are DSLRs. I do mostly DSLR photography. But if you want to photograph the night sky, you're going to need to take some time exposures. So you'll need some way of tripping the shutter remotely, either by computer. I do it mostly by computer, but you can start out with one of these as well. This is just a remote, shutter remote. And you can take some nice wide field views. What I have on here is just a standard Canon lens with that comes with the camera. And it happens to be a very good astrophotography lens. It's well corrected and nice color. And so that's how you can start out. You can take star fields, wide field shots of the night sky. You can put on a zoom lens, get a little closer in, and you can take some star trails of the night sky, so you can watch the movement of. You can take video with these things. A lot of people are doing video. I don't do too much video because it requires a really powerful computer, lots of memory, which I don't have on my computer. So, but a lot of people are doing very cool, and this is all the equipment they really have to have.
So you could shoot the moon or planets with
yes.
Something like this?
Well, no. You'd probably need a little more focal length to shoot the moon than this lens. It'd be a very small dot.
Okay, so this is more wide field?
More wide field stuff. So we'll get to that when we get to some of the pictures. We'll show some of the stuff taken with just this camera lens. But moving on, you can also hook your camera to a telescope. This is a nicely well-corrected telescope. It's like a camera lens, but you have to adapt the camera to the telescope. And we do that with what's called a T-ring. This thing detaches and actually just slides into the eyepiece holder. This is a 2-inch eyepiece holder.
So the camera is in place of the eyepiece?
Yeah, in place of the eyepiece. And so you can do it that way. If you move to a telescope, then you need some way of guiding or tracking the night sky. And so that's what this big mount is for. This is a tracking platform because the Earth is turning and you need to counteract the rotation of the Earth. So this has got a clock, kind of, I guess we could call it a clock drive, motors. You can't see that they're on the other side. But they turn at 24-hour clock rate, and then they just counteract the motion of the Earth. So it's going to kind of turn like this at clock rate and track the night sky. This has to be pointing to the North Celestial Pole, or near Polaris.
Right.
And you're probably going to need one of these devices or some way to get polar aligned, it's called. This is called a pole master. Very essential piece of equipment nowadays. It's still relatively new, but it has quickly become an indispensable piece of astrophotography equipment. Gets you on the pole really quick. You do not need a mount like this if you're going to just track with camera lenses. You can take your camera and put it on a tracking mount. It doesn't need to be nearly as elaborate as this if you're only going to do wide field. This is if you're going to put some magnification on it. You need a good sturdy mount so that there's
you don't
no
need
vibration.
It wiggling and wobbling.
Yeah, but so you know, there are tracking platforms. It would be just a little motorized piece that goes on your tripod. And that would, if you're polar aligned, that'll track the night sky as well. So there's various ways to track the night sky. This is if you're going to use a telescope with magnification. So a lot of my wide field shots are taken with this particular telescope. And then I have a more powerful telescope in the observatory, which we'll show you a shot of in a bit, that you can take more close-up images. If you're going to do planetary, you'll need more magnification. So that's 2,800 millimeters magnification. Plus I can double, triple, quadruple that and really zoom in on the planets. So for planets, you need lots of magnification. For wide field extended objects like nebula and some larger galaxies, this telescope's a perfect instrument for that.
Now, we did want to mention for our viewers who might not be familiar that this is a refracting telescope using lenses rather than mirrors.
Yep. But it's a well-corrected refractor. So
in other words, the color aberration has been...
Yeah, spherical and chromatic aberration have been eliminated in this telescope. You might notice the other scopes on top of it. That gets into the next level of astrophotography is getting accurate tracking and guiding. So this is a guide scope here and here. I can guide in either one of them. I usually guide in this one, and in the eyepiece holder I have another little camera. This serves as both a guide camera and a planetary camera. So I can either image the planets with this, or I can slip it in here or in here and guide on a star. That picks off a guide star and keeps the telescope drive fixed on one point in the sky. So
would that make up for any periodic error correction that might...
Yes, it'll do that and more. It'll keep you on one pixel. So all your stars will be pinpoint. It'll do all the correcting you need. You need to have good focus. So I want to touch on a focus mask. I usually use something like this to focus. That's called a batten-off mask. There's another way, if you don't have a guide scope, if you don't want this elaborate, you can buy one of these things which replaces the T-ring, oops, and attaches, well, instead of the tube, this thing will attach here in front of the camera, and you can put your guide camera inside that port and guide in front of the camera like that without the guide scope.
In place of that?
Yeah, so you can do without the guide scopes as well. So lastly, then, moving up in focal length, I have a picture of my other telescope, which is in the observatory. You'll see it there. And so that's basically the same mount with a different telescope on it. This is what I'm going to use for planetary, solar system, and some smaller objects, distant galaxies, etc.
What's the type and size of this particular telescope?
That's 2,800 millimeter SCT, Schmidt-Cassegrain telescope.
Okay.
And just like if you're shooting any photography, this is a form of nature photography, astrophotography is, and you're going to need a variety of lenses, a variety of focal lengths to work with. So this is my telephoto, if you will, in astronomical terms, though. And the other telescope we were looking at here in front of us is more of a wide field telescope. So the next slide shows where I have the longer, I've got it, now it's mounted up north in an observatory. So I'm doing a lot of work from that. And my latest work is a picture of Andromeda. Because I'm working with so much focal length with the big scope, I have to do it in multiple segments, or mosaic, if you will, because Andromeda is too large of an object. It's 5 full moons wide.
Yeah.
And
so the black areas that we see there, you're waiting to add that data?
That's right. I'm not done with that. But the advantage to doing mosaics is you get the resolution of the bigger aperture, which is important when you want to really zoom in and look at the detail in these objects. And
that's a fantastic image. I can't wait to see the finished product.
So that's my those are my rigs in a nutshell.
But again, anybody can start off simple and then work their way up depending upon their budget and level of interest.
Absolutely. All you need to do to start, and I would encourage that, is just start with a camera and tripod, point it at the night sky, and see what you get. It's fun.
And just go from there. And this is really a very interesting setup. And in the next segment, I know we're going to take a look at a number of images that you have
I'll show you
taken,
some of my work.
And we're looking forward to seeing those. We're going to take a quick break right now. If you have any questions about this topic we're talking about tonight, or really any other topic, please send us an email And I did want to mention, we do appreciate the comments on YouTube that you folks place there for us. Those are quite interesting, and we'll be getting to some of those in a future show. Before we continue with this segment of the show, or the next segment I should say, we're going to take a break, and we're going to have our own Stephen Whitty with Term of the Month.
The term of the month is green. To the eye, stars shine due to their temperature. The spectrum brightness curve has a peak frequency or color. The sun's peak is in the green, however, the sun appears white. When the radiation peak is plotted for stars of a variety of temperatures, one gets a Planckian locus, shown here. This locus passes through red, orange, yellow, white, and light blue, but green is absent. There are no green stars. Part of the problem is that stars that peak in green also emit much in blue and red, and the human visual system interprets this as white. Human vision is complicated. Perceived color can be altered by nearby colors. A blue object near a red object can appear greenish. So Antares B is a blue companion of a red supergiant Antares. This is the canonical example. Neptune appears blue for the most part, but methane in the upper atmosphere absorbs red, leaving Neptune with just blue and green, and it can appear green or even aqua. And Uranus can also be seen as green for very similar reasons. And that's the term of the month, green.
Thanks, Stephen. We're back talking about photographing the night sky. We're talking with Tony Licata, one of our club members at the Ford Amateur Astronomy Club. Now, Tony, in the first part, we talked about the equipment, what you used to get the pretty pictures, and so now we're going to take a look at them.
Yeah, and this is why I do this, because it's kind of an art form for me. I'm an artist by trade. I didn't start out that way. I thought I would be a physics astronomy major for a while, but quickly learned that's not, I didn't have the head for that, for all the math, so I moved into something I am good at. And so now that I'm retired, I can do a lot more of what I enjoy the most. So this is a creative outlet for me.
Oh, great. Well, let's take a look at some of your creations.
Cool. All right, this first shot is star trails. Now, we talked about just starting with a camera and tripod, and this is the sort of thing that you get if you just put a camera on a tripod and let the night sky move as it will. The first one is a few minutes, maybe a 30-minute exposure to an hour exposure maybe, and the next one is maybe more like 4 hours of exposure.
That's the circular one that we see on the right.
That's right. Now, moving up the focal length ladder, you see you can put a little more focal length on, and you can take pictures of the Milky Way. But in this case, now we've put the camera on a tracking mount, which we talked about earlier. And you can see here some of the Milky Way and some red nebulosity there and some stars. Those stars are pronounced because I use what's called an anti-Newton filter over the lens.
And this is an example of wide field.
Right, and that helps, the filter helps pick out the constellations.
Okay.
As you can see here, some of the constellations, you got Cygnus there, Cepheus, and it also, this filter brings out some of the star color. If you can see it on the screen, some of these stars are either very red or blue, so the anti-Newton filter works well to bring out star color. Again, using the anti-Newton filter, here's a picture of the constellation Orion, and just more wide field work. That big red glow to the left of the image is actually an aurora that took place during this imaging session. And and this was from the same night. It actually got in the way of my astrophotography that night.
But it's still a great shot, Tony.
Yeah, you have to work with the opportunities that present themselves sometimes. So, and then now, applying even more focal length, you can take pictures of the sun or the moon. In this case, this is the sun. You have to use a filter for this. Never look at the sun unfiltered, or you'll burn your eye. But this is a shot through a telescope, a shorter focal length telescope. During the Venus transit, that little dot up to the upper right is the planet
I was
Venus.
going to ask if that was Venus or
Yes,
Mercury.
it is.
Okay.
It's Venus, and it's transiting the disk of the sun. You see a lot of sunspots as well. Again, this was a long focal length. This was, I think, an 800 millimeter camera lens, just mounted on a tripod during an earlier eclipse. This is not this summer's eclipse. This was a few years ago.
Okay.
Oh, and we were near the airport, and you can see at the bottom, you can see a jet eclipsing
Tail
the
fin
sun
of the
along
yeah.
with part of the moon eclipsing.
You didn't Photoshop
the sun.
that, right?
I did not Photoshop
Okay.
that. That
All right.
actually happened. And there's a gigantic sunspot during that eclipse, too.
Oh, that's
that was
great.
That was a fun event. That was here in Detroit Metro. Now, this summer's great American eclipse, I did get out west to image that. This is a combination of several frames put together into one so that we don't burn anything out. And we also get the Earth shine on the surface of the moon. Earth shines back on the surface of the moon during an eclipse or a new moon phase, and this combines 3 or 4 images into one.
And you've got the beautiful corona.
Corona is captured as well. Next slide. So again, now more focal length.
Okay, moving into the solar system.
Yes.
Okay.
This is with the larger telescope, not the one we have here in the studio, the one up at the observatory. We need a lot of focal length to do planetary and solar system imaging. So this is the planet Jupiter, obviously. And this is taken with that little guide camera that I said substitutes for a planetary camera.
Oh, I see.
Next. Saturn as well. Another good opportunity. Seeing planetary imaging is very subject to seeing conditions, and 2 or 3, 4 nights per year in Michigan is about all you get for good planetary imaging.
It would be the steadiness of the atmosphere, or the
unless you're out there just every minute of every night, which I don't have that kind of time. But yeah, next slide, please. Then other solar system objects are comets. We can image various comets that go by. This is taken with the scope here in the studio. Next. Next, please. And then again, with this shorter focal length, this is a 540 millimeter shot of the Andromeda galaxy. Earlier you saw the mosaic I'm putting together of Andromeda.
Yes.
It doesn't look any better than this one, but you could not zoom into this one and see the amount of detail that you see in the mosaic that I'm working on. So as I finish up and work on the processing, I hope to have the best of both worlds, is beautiful color and detail at a distance, but you'll be able to actually zoom into that image and see more than the wider field scope can show.
All right.
More galaxies with the longer focal length, 2,800 millimeters telescope. This is native focal length. Next. And the amazing thing is that scope has a great deal of resolution, and you can begin to actually see the individual stars in distant galaxies. This is M33, and you're actually picking out individual stars in that galaxy. These are outside of our own galaxy of stars.
This is, wow.
So that's the benefit of having the extra focal length. The 4-inch telescope will not be able to do that.
Okay.
That's the aperture brings resolution. This is M13, globular cluster. Again, with that bigger aperture, you're seeing individual stars in M13.
And as I look at this, you're really looking down into the core, and you're still picking out individual stars.
Yes, and there's some 300,000 stars in that object. Next slide.
Fantastic.
Next slide, please. So this is a wide field, again, we're kind of bouncing around here, but this is the Bubble Nebula, and wider field through the 500 millimeter telescope. But the next slide is zoomed in with the bigger telescope, again getting that extra resolution and delineating the stars even better.
You can see that, plus you can actually see the edge of the bubble itself, right there in the center.
I should mention this is taken with a hydrogen alpha filter.
Okay, which helps
bring out the reds. Next. Again, with the hydrogen alpha filter, this is called the Pac-Man Nebula. Next. And again, this is bouncing back to the 500 millimeter telescope. This is, of course, the Great Orion Nebula, and the Running Man is the blue nebula next to it. Next slide, though, is with more focal length using the big telescope. We can see, it may be a little burned out on your monitors at home, but you can see what's called the trapezium region, which is the star-forming region.
I was just going to say, yeah.
Of M42.
Hopefully all of our viewers are watching with a nice high-res.
Hopefully.
Yeah.
Next. And then, of course, the Pleiades, the Seven Sisters, which is M45, getting some of the nice tidal...
that nebulosity?
Tidal, yeah. Next slide. More wide field, or 540 millimeter shot through the scope that's here in the studio. This is, of course, the Horsehead Nebula and surrounding regions. And then zooming in again with the larger telescope and the hydrogen alpha filter, we get even greater detail on the Horsehead. Next slide. And my last shot here is of, this is called the Veil Nebula.
In Cygnus,
This is
right?
in Cygnus. And this is probably, like most of these, this is probably a collection of 20 or more. This is probably more like 50 frames at 5 to 10 minutes of exposure time. These are all combined digitally, and because the idea in astrophotography is to present the data without the noise. So there's various methods we use in post-processing these images. These aren't just snapshots. These are long exposures, and they are assemblies of long exposures. So multiple 5 to 10, maybe even 15-minute exposures.
So you're using various computer programs to assemble and massage, if you will, the data in order to get them.
Yes, and we're taking dark frames and subtracting that noise from the images and stuff like that. So there's a lot of processing to present the data that you worked hard to collect.
And that's a whole nother program.
That's another presentation.
Yes, indeed. Well, I want to thank Tony for coming to the studio today and presenting us this information on the equipment that can be used starting very simply or stepping up a little bit higher. So thanks for coming today, Tony. Appreciate that very much. Please check out our club website. We have the email address down at the bottom of your screen. Give you a moment to jot that down. And coming up next is Stephen Whitty with What's Up in the Night Sky. Stephen?
What's up in the night sky for January 2018? Now the sun rises around 8 and sets around 5:11 p.m. At the beginning of the month, and then just a little earlier it rises at 7:47 and sets a little later at 5:46 by the end of the month. Astronomical night is about an hour and 40 minutes, plus or minus, throughout the month. We start the month with a full moon at perigee, so that's when the moon is the closest to the Earth. And when it's closest to the Earth, it's as big as it gets, so people have started calling this a supermoon. We also have a full moon on the 31st, and since perigee is the day before the full moon on the 30th, that's also an extremely big moon, so I'd call it a supermoon too. Third quarter on the 8th. November, up right, we have a new moon on the 16th. We have first quarter on the 24th. On January 1, Mercury is in Ophiuchus, and by the end of the month is in Capricornus. Here, though, you can see the sun in the center. To the left is Pluto, to the right is Venus, and right there at the sun is Venus. Saturn, and then finally Mercury. Of these, really Mercury is the only one you're going to see, and that's because on the 1st, Mercury is at western maximum western elongation. It's also at aphelion, so farthest from the sun on the 25th, so it's not terrible at the end of the month. It's just better at the beginning. Saturn is in Sagittarius. It rises 7:22 to 5:38, but it's best at the end of the month and, half hour to an hour before sunrise. Both of these are fairly bright, with Mercury at magnitude minus 0.2 and Saturn at minus 0.5. On January 9th, Venus is in Sagittarius. Well, actually, it's not in Sagittarius so much as it's at superior conjunction on the 9th. So if you draw a line, and I've gotten a line drawn, from Earth to the Sun to Venus, you can see that Venus is right on the other side, superior conjunction. If you continue that line in that same direction, you get to Pluto, also on the 9th. So Pluto also has superior conjunction. So Pluto is not very good at all month. Venus, however, is best at the end of the month. Mars, here again on the first of the month, so you see Mercury there. Mars is in Libra, going to Scorpius by the end of the month, rises 3:30 to 3. It's best at the end of the month near sunrise. It's magnitude 1.5. It's not quite as bright, but it's still pretty bright. Jupiter is in Libra. You can see Jupiter right there near Mars. It rises about the same time, 3:47 to 2:10. It's also best at end of the month. It's magnitude minus 1.7, which is really bright. And then finally on January 1st, again, Uranus and Neptune. Uranus is in Pisces. It sets around 1:30 in the morning to just before midnight by the end of the month. It's best at the beginning of the month near sunset. And Neptune is in Aquarius, where it's been forever. It sets at 10 o'clock, 10 p.m. and down to 8 p.m. and again is best at the end of the month. Now, Neptune is near a bright star. It's a mag 3.8 star in Aquarius, and in this shot, Neptune and this bright star really are so close you can hardly tell the difference between them, but they are slightly farther than the width of the full moon away from each other. So in a telescope, Neptune is visible. The quadrantids is a meteor shower on the 3rd, the night of the 3rd into the 4th, and really be after midnight is probably best. It only peaks for a few hours. We've got a full moon. That's the quadrantids. And that's what's up for the night sky for January 2018.